All right, guys. In this video, we're going to explore questions 31, 32, and 33, which is on the next page. Now, 31 says, Amy has 6 blue, 2 red, and 3 green blocks to arrange on the shelf. In how many distinguishable ways can the books be arranged if the books of the same color are identical? So, when we are trying to arrange items that are considered identical, we're going to use the permutation formula for non-distinct objects, non-distinct items. Sometimes we call this distinguishable permutation. The formula for distinguishable permutation says n factorial, n meaning how many books I have in total, divided by k1 factorial times k2 factorial all the way to k of m factorial, where k1 will be how many of the first type of books that I have, which means there are 6 blue books. K2 will be how many red books that I have, and then so on and so forth. And we're using this formula when we're trying to find out how many distinguishable ways or distinct ways can the books be arranged if 2 books of the same color are identical. So I need to find out how many books I have first. And to find out how many books I have first, I'm going to add the 6 blue, the 2 red, and the 3 green. And I have 11 books in total. So for number 31, n equals 11 books. K1 will be the number of blue books. And there are 6 blue books. K of 2, or case 2, number of red books. There are 2 red books. And K of 3 will be the number of green books. There are 3 green books. So now we're going to use our distinguishable permutation formula, and we're going to find out how many different ways can we arrange the books. So my numerator, that is going to be 11 factorial, divided by, and my denominator, that is going to be 6 factorial times 2 factorial times 3 factorial. Let's go into my calculator. And you guys can use your TI 83 or 84 calculator by going over to Math, PRB, and then selecting the 4th option, which is the factorial notation. But for 11 factorial, that is going to be 39,916,800. Divided by 6 factorial, which is 720. 2 factorial, which is 2. And 3 factorial, which will be 6. And remember, to work a factorial, you're starting from that number and you're multiplying it down to 1. So let's multiply my denominator. Why did I put a 6 factorial down there? I wouldn't know. So 6 times 2 times 720. That's going to be 8,640. Now we're going to divide that in my calculator. Six 800 divided by 8640, 4,620 ways. And that is how we approach this problem, number 31. So I hope number 31 made sense, because now we're going to move on to question number 32. And number 32 says 10 people are bowling. 3 will use a black ball and 7 will use a blue ball. How many different black and blue bowling balls sequence can occur on the rack? Once again, we are going to use the permutation for non-distinct objects. Because when it comes to a bowling ball, 2 bowling balls of the same color, to me, looks identical, and so they'll be considered identical. Now, same process. There are 10 balls in total, so n is going to equal to 10. K1 will be the number of black balls. And there are 3 black balls. K2 will be the number of blue balls. And there are 7 blue bowling balls. So now I'm going to use my permutation formula for non-distinct objects, or you can call it the distinguishable permutation formula. So it's going to be n factorial. So 10 factorial in my numerator divided by k1 factorial, which is going to be 3 factorial, times k2 factorial, which is going to be 7 factorial. We already know what 3 factorial is from the last question. That is 6. Let's find out what 7 factorial is in my denominator. Okay, what's going on? 7 factorial. That is 5,040. And my numerator, which is 10 factorial, that is going to be 3,628,800. and 800. When I multiply my denominator, that's going to give me 30,240. Doing it off the top of my head, but I know it's going to be that. So I'm going to divide my 3,628,800 by 30,240. And when I do that, that equals to 120 ways. All right, guys. I hope that makes sense. Hope you guys are understanding how to use the distinguishable permutation formula. Use it when you're trying to arrange objects that are alike. So you see I did my work here. Number 33. It says, how many distinguishable permutations of letters are possible in the word Tennessee? Let's first find out how many letters are in the word of Tennessee. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 letters. Now, we're going to call K1 the number of T's that is in the word Tennessee. And it's only 1 T in that word. We'll call K of 2 the number of E's in the word of Tennessee. And in Tennessee, there are 1, 2, 3, 4. Those are 4 E's. K3 is going to be the number of N's in the word Tennessee. and there are two N's in the word Tennessee. And then K of 4 will be the letter of S's in the word Tennessee. And there are two S's in the word Tennessee. So once again, we're going to use the distinguishable permutation formula. 9 letters, so 9 factorial divided by K1 factorial, which is 1 factorial, times K2 factorial, which is going to be 4 factorial, times K of 3 factorial, which is 2 factorial, times K4 factorial, which is once again 2 factorial. Let's calculate our 9 factorial. That is 362,880. 1 factorial is just 1. 4 factorial is 24. And the 2 factorials are just 2. So 362,880 divided by, when I multiply my denominator, that's going to be 96. Divide that by 96. And that's going to equal to 3,780 distinct orders. All right, guys, that is it to number 31, 32, and 33 using the distinct permutation formula or the distinguishable permutation formula. Hope that made sense. Hope you guys enjoyed the process. I'll see you soon. Take care.